Well, thank you all for coming to my presentation. I'm really passionate about all things actor development, and I see a couple of y'all are too. So this is very exciting. My name is Whit Waldo. I'm the CEO and founder of Innovian. I build custom software applications for companies that need it. Like I said, I'm passionate about actors. I wanted to share some of my experiences with you in doing that. I think they're a very useful framework, if not a framework filled with potential pitfalls. Has anyone ever used Dapr? One person, great, wonderful. So that's why I added this slide. So Dapr is a platform for microservices development. So the idea is that it's a collection of abstracted building blocks for getting and saving state, or getting and retrieving state, for publish and subscribing messages, encryption, decryption, just a bunch of just kind of abstractions of general APIs, an actor implementation, workflows, and more. So why would you use Dapr? It's so that if you are swapping from one vendor to another, your dependencies, you don't necessarily have to take the time to retask your developers to go and learn a new SDK. You write it once against Dapr, and then swapping out the vendors, just change out the configuration file. Let's see here. So actors. Has anyone ever worked with actors before? Okay, 2 people, 3 people, wonderful. So an actor is, I like to think of what it's not. So if you're saving data to a database, you have a record, has an identifier, has some number of properties with it. But once you can insert it, you can update it, delete it. But once it's there, it's static. It stays put. It doesn't really do anything on its own. An actor is more like a program that replaces that record. So it has its own state. It has its own series of operations it does. It can do it on its own cadence. When it's done, it'll offload itself. It's a way to think about building multi-threaded apps in a really simple single-threaded model. Multi-threaded apps will often have complexities around, accidentally accessing the state from other threads. Potentially introducing deadlocks. It can get really messy really fast. Actors provide a way to just think about it in bite-sized pieces and not have to worry about a lot of those complexities. So where would you use actors? Actors they're not a general purpose replacement. I personally use them a lot for event processing. So I build a lot of ETL software. You're pulling data from somewhere, you're transforming it in some way, you're putting it into something else. Dapr, in the last release in 1.15, we released the Dapr workflows, and that is, again, kind of the same sort of thing, a code-first way of taking data, transforming it, putting it somewhere, but again, it itself runs on top of actors so that you don't have to really worry about any of these potential problems. You just kind of say, here's what I want to do, go forth and schedule it. Someone contributed an agentic framework, so we're currently working on kind of maturing that. That will come out with 1.16 to just kind of write agentic workflows again in a way that say here's what it is I'm going to do. Here are the different agents implemented as actors, and go forth and do these tasks. It's also common for games. So Unity actually calls these each of the objects actors. Specifically with regards to Halo. Halo led to the development of an actor framework called Orleans that's still pretty commonly used today. Orleans was a precursor to developing service fabric actors. Dapr actors are a next generation of those as well. So if you've ever used any of those, they're all very similar to one another. I'm going to be talking about Dapr actors today, but a lot of the concepts here are related to the other ones. So I guess we're largely going to look at 5 aspects of actors, kind of the features of them, and where some of the pitfalls are, and how to kind of think about that as imagined in more of a concrete implementation. Well, we'll get to that. We're going to talk about the domain of it. When you're talking about the different objects that make up your application, where does it make sense to split each of those objects out into separate actors? Where does it make sense to kind of put them all in one place? When is an object a property of another actor? When should you just say split that out separately? We're going to talk about how do you store the state inside the actor. One actor cannot access the state of another one. We're going to talk about how to identify the actors. You can absolutely pass around actor information from one to the next. Actors are partly an exercise in how to minimize data transfer that you could otherwise infer through your application design. We're going to talk about kind of the turn-based processing. That's a aspect of the single thread nature of these, and that messages come in, the actor must handle the message, finish processing it before it can move on to the next one. And then finally, how do you get the data back out of the system? It's this is kind of one of the biggest ways in which it kind of diverges from really database-driven processing, and that it can be difficult because of these other aspects of actors to actually get the data back out of your system or otherwise do something with it. So first, the data-driven design. It's definitely far more of an art than a science to really design these things. My general rule is if the object itself, if what you're doing with it is more CRUD operations, create, read, update, delete, you probably do not need a separate actor for that. Instead, that can be implemented as a property of some other actor. If it's something that's doing kind of unique operations, you need to reach in and have it do some kind of calculation, something specific to it, especially if it potentially involves other actors, other types. Split that into another actor. If it needs to do something on its own cadence, it's going to do something every 5 minutes, every 5 seconds, or just as quickly as it can, put that in an actor. Just make that a standalone unit of work. So, but it's largely going to just kind of depend on what's involved in your application, and really how chatty it is with the other actors, the other services in it. I'm going to kind of describe all of this and kind of give a concrete representation of everything in an imagined game of Tetris. Everyone knows how to play Tetris, so this is kind of an easy example. But you have a number of events. So some of them are user-driven, some of them are system-driven. So when the user is going to go left or right, they want to move the active piece around, they want to rotate it. A soft drop, a hard drop. Each of these needs to come in and be handled in some way by the system. At the same time, there's system-driven events such as a piece has been locked. It's no longer an active piece. We need to draw another piece out of the bag. We need, because it's been locked, maybe there's a completed row, it's time to clear that. That needs to be handled in some way so that the larger game is aware of it. The user, because of the input, the piece is now moved, it's rotated, it's translated in some way. Maybe the game has started, the game has ended. But then the actors themselves, when deciding how to build this, it's implemented using only 2 actors. So I decided on the game itself, because that's going to be, when the player wants to play the game, they'll start a game. That's going to be its own thing. It has its own properties. It has the fields that is represented by the game. So what is the grids and the columns that represent each of the cells? Those cells themselves, what's in each cell? Is that which color piece from a styling perspective? Is it a ghost showing where the piece will go? Is it the active piece and that it can move between the cells? The game itself also has the bag collection. So if you know anything about Tetris, the pieces are not actually random. You don't get a random piece every time. It's a bag of the 7 possible pieces. Those are randomized, and then so you always get each of the 7 pieces before you move through it. The other parts of the application don't need to know anything about that. That's something that's very specific to that game of what are the next possible pieces to come out. And so that makes more sense to put that as a property in the game itself and let that care about that, but not necessarily make that a separate actor because it doesn't do anything else with the rest of the system. The blocks in Tetris are called tetrinos. And so that makes up the second actor in the system. Is they have their own rotation, they have their own position in the grid. They have their own little block type. Those are all properties of the actor, but you don't necessarily need rotation itself to be represented as an actor because it's an aspect of the block itself. And then again, you really just need those 2 things. You could always add more. You could say, I want a leaderboard. I want to track the stats of individual players. We'll kind of look at some examples of that as we go. So state management, everything in Dapr is implemented as a key value store. And so while we hope to have future stores in the future, that's what we got today. In the .NET SDK of actors, we implement everything with a cache. That's going to be really useful for a game like this in that when you retrieve the data the first time, it's going to be put in the cache. When you write the data, we're going to update that as a bulk transaction at the end. But otherwise, it allows for really rapid reads without necessarily taking on the cost of reach out to that abstracted state type and retrieve that every single time. Otherwise, keys can be any string-based value. So that gives you some flexibility. Is it something that you're putting in state against a known name? Maybe you're constructing some more of an advanced key. And we'll kind of look at that in a little bit as well. But when you're thinking about the data that you're storing, it's important to think about what kind of data are you storing and how are you accessing it. If you're storing small bits of data, integers, longs, strings, those are easily read and written back because they're small amounts of data. If you're storing kind of complex objects, you may not necessarily want to deserialize, read, process in some way, make a change, reserialize, put it back into state as a constantly happening operation. Lists are particularly bad. So, I mean, we'll serialize wherever you give us. It's all JSON encoded. But you probably, a list gets longer. You always are adding more things to the list. So as that list itself is getting longer, it's going to take longer and longer to read the entire thing out, append another value to it, write it back in. So when you're thinking about how to design, how am I saving the stuff in here, you can use lists, absolutely. But you want to largely think of it in a more partitioning style. If you are storing, I don't know, the IDs of the games the player has played over time, you'll want to, maybe you have one list that keeps track of here are the months that the player has actually played games, and here are the days inside of those months in which games were played, and then each of those, a key, based on the actual days, here are the lists of the games that were played. A person's probably not going to play a whole bunch of games, and so you can now have these small, more granular lists that are more easily accessible by those keys. So in this case, we would largely have two kind of sets. I guess we got the two actors. So our game actor largely just has simple data. We have the play field itself. That's largely the columns and the rows containing each of the cell data. We have the game rules. Maybe the person wants to start the game at a layer level. You'll have the number of rows that are cleared. With regards to Tetris, the number of rows that you've cleared defines, you can calculate what the level is. You can calculate, what's the speed at which the blocks are dropping from that. You need to know, Tetris has a mode you can hold the tetrino and recall it later on. So is there a tetrino being held? What is it? What's the current state of the bag? Where are the next pieces coming up? Where are the previews? And then, a flag. Is the game actually active or not? So in Dapr, all actors are virtual, meaning that they are not really ever instantiated. You can reach out at any time with any ID, invoke some action, and it will respond as though it's always been. And so if you have a flag in there that just says this game has ended, you just know, hey, okay, the game has ended. Maybe I need to reinitialize this because somehow my GUID is conflicting. The tetrino actor itself, though, because it is, it's going to have the properties of the tetrino, the rotation, the position, what kind of block it is. Every time the tetrino itself is doing some operation, it's going to be looping on that data. So instead of having that kind of split out into these separate states, it makes more sense to put that into one object because you're using it all the time. So then how do you identify the actors? It's kind of going to be similar to interacting with a state, in that each actor itself has a unique ID attached to it, and it's unique for each type. So you can use that ID across multiple types, and you won't have any kind of a conflict. I covered the kind of the virtual nature of them, but yeah, it says that if you may say, hey, I just want to have a unique ID every time I assign one of these actors. You may say, again, like the state management, they're string-based. So you come up with kind of more elaborate strategies about how it is that you develop the keys to access each of these. So kind of going to the example again, if you've got the game actor, every time you're going to spin up another game, you might as well have another unique ID for it. Dapr, you can configure it to put a TTL on actor state and say, after 2 months, delete it all. You could not. And so you may want a distinct ID so you can recall the state of previous games at any given point. The Tetrinos themselves, it doesn't make any sense for them to have a separate ID. So you could, if you really wanted to, but once the Tetrino is locked at the bottom of the game, you don't need it anymore. It's really, you care more about the cells, and do you have 10 cells in a row so you can clear the row. And so instead of having to pass the message to say, how does the Tetrino know which game it belongs to, or the game know which Tetrino are we paying attention to, have them share the same ID. Then they know which game they're attached to because it's the same ID it's already on. You don't have to share that message. If you have a player, kind of like the game, create a separate ID for each of them. I like GUIDs because they never repeat for all intents and purposes. A leaderboard is kind of different. A leaderboard or a game manager, something that kind of keeps an overview of everything. You typically don't want to have singleton actors because they're intended to be kind of more representative of parallelized work, but sometimes it makes sense. So it's a great use for the empty GUID, all zeros but the 1 4 kind of in the middle, because there will only ever be one leaderboard. If you can minimize the number of calls that are made into it, the number of operations it's doing on the blocking turns, then if they're going to be relatively low traffic anyway, then it's perfectly fine to have a singleton instance that essentially just says, here's what's going to store all this information so that I can recall and say, what are the top 10 games that have been played? What are all the games that are currently being played? Where are all the active games? So that'll kind of take us to the turn-based processing. In Dapr, and this is true of Service Fabric, of Orleans, of Dapr, when messages come in, they're blocked until the Dapr is able to process them, do something with it, and then release that back to the runtime. And so that means that most of these messages will have some kind of a timeout attached to them. So whatever it is that information's coming back into the actor, you want to handle that very quickly because you don't know what other information is currently queued waiting to come into that actor as well. There is re-entry support. That kind of means that if one actor receives some work, it needs to put that into another actor, and for whatever reason that actor needs to come back to the first one and do something else, it allows it to re-enter without actually starting another turn. So when that other work completes, it completes over here, it comes back, now that turn is complete. While that's available, you want to be careful about doing that because if one of those downstream operations locks, then you're going to wait for that entire turn to time out at each of those instances, and that can be problematic. It's available because there are perfectly reasonable scenarios in which you need that, but not necessarily. Finally, background processing. So when you're thinking about designing the actors themselves, again, it focuses on the turn base, but that has more to do with the input coming into the actor and less to do with what the actor itself is actually processing. In this case, we have a game. The game loop itself is on the Tetrinos. While you can schedule things at 1 second resolution in Dapr itself, the problem with that's kind of slow for a game like this that needs to do something maybe every 250 milliseconds or so, or faster as you go up higher in the levels. So instead, you can do create background threads on the actors themselves. They won't honor turns. So you want to be kind of careful about doing this. But you essentially create a background thread on to loop through, create that game loop on the actor itself. As new work comes in, that will be governed by the turns, but it can still take actions on the actors themselves. Whatever it is that's processing, in this case a game loop, and do that higher, faster resolution, that higher work processing in that background thread. Complete that when you can and pass that back forward. So in this case, kind of going back to our game example then, you kind of want to think about, and this kind of goes back to how it is that you separate out the different domains here. What's the frequency at which each of these events are going to happen? What's the weight involved? So the event's going to come in. What needs to happen as a result of that, and how complicated is that? So what's going to be You don't want a super high frequency, really long processing operation to happen against the same actor. So split that out. So to the extent you're able to, minimize the crosstalk between the actors so that those things that do need to happen frequently, make them lightweight operations. Those things that may take a long time to happen, make them infrequent operations. And then finally have extracting the data. So how do you get this information back out of the system? There is no way in Dapr to query all the activated actor IDs at all. So if you have activated something and you need some way of going back into them, you're going to need to either keep that in an actor somewhere else or think about that and how you've designed it. There's no limitation on using the other building blocks in Dapr. So if you need to put something in PubSub, and push that out so that other things can subscribe to that, that's an option. And then, just when you're thinking about this, at what kind of a time resolution do other services need to access any of this information? Do they need it kind of more of a, I'm requesting it because I need to do something with it now? Or again, can it just kind of subscribe to a topic somewhere and eventually catch up with the rest of the system? And so to that end, there's kind of like 4 patterns of how you'd access any of these. You don't want a bunch of clients to talk to one actor. If you're doing that, they're very likely to time out waiting for those turns to complete, and that's going to lead to some deadlocks in the system. It's perfectly okay for that client, by the way, could also be a separate service or an actor. Perfectly fine for those to be one-on-one. The idea is largely going to be push the data forward. Don't minimize the number of things that the downstream thing needs to call back into the upstream. Have upstream constantly push downstream. So, and because turns are only relevant to inputs to actors, not relevant to the outputs, you can easily have an actor, say, hey, here's spin up 100 actors to split up the work that I've received to handle that downstream. You don't then want 100 things to all contact one actor. So one actor talking to 100 things, perfectly fine. And then of course you could pass it into a PubSub topic. While there is not support in Dapr right now for PubSub directly on actors, that is scheduled to come in the summer release to have individual actors be able to subscribe to topics and activate themselves when new messages come in, as determined by filtered by the runtime. That's it. I've been working on building out a sample that I'll be publishing in the .NET repository at some point. But thank you very much for attending my talk today. Does anyone have any questions?
Let me take the mic.
Yeah, that'd be great.
Stay down there. Okay. So if I understand correctly, kind of applying this to the classic microservices way of doing it, right? An actor is a microservice.
Yes.
That's a one-to-one thing.
Yes, an actor is a microservice. Where services are often considered to be multi-threaded in themselves, and that if you think like a web server, it can receive requests all the time, and it can also respond back to those. An actor is more of a kind of a standalone, not meant to be a full featured thing, because it can only receive one thing at a time, and it has to finish processing that one thing before it can move on to the next thing.
And then you have to use the mic.
Okay.
But I recall there like internal queue storage, felt like we had to do something custom there, and we came up ordering, and then also like what if that actor goes away for some reason,
Sure.
and then so we had like a centralized controller that kind of reconstituted.
Sure.
Is there does that have any those capability?
So if I understood the question, is if something happens to the actor, if it crashes, what have you, do you have some way of kind of recalling that state so it's not completely lost? And it kind of depends. So if you're putting it on the background loop as I described, no. So that because that's happening independent of the state, anything that's saved to the cache is gone if it's never persisted. But at the end of a turn, it does persist everything, and the .NET SDK offers a way to proactively persist that state. If it's something that needs to happen, it has crashed, schedule a reminder for it. Don't use timers. So if a timer, if the application crashes, timers will be lost. So anything that's happening in the memory of the actor, anything that's happening on a timer, that's gone. But if you schedule a reminder and you say, hey, every time I change something, go ahead and save all the change state to disk. Then when that reminder happens, if this has died in some way, resurrect it in 5 minutes and pick up where you left off based on what was last saved.
Is there like a controller that's kind of like managing that, or?
You'd have to build your own service to do that. So like in my example, the game manager, where while I'm not keeping track of the individual games themselves, because once they've run, I don't really care, except maybe for the leaderboard. If you have your own separate game manager, you assign the IDs to that and just say, these are the ones that are current. You could say when the game completes, have them call back into the game manager and say, the game has ended. And, and I can, partition that in a list as I want to. So actors kind of, that would be one of those use cases for kind of a singleton. Where it either is keeping track of it. Again, it may, if you have a lot of robots, you may want to keep track of that, come up with a more distributed way of thinking about that as well, so that you don't run into the problem. If it's routinely getting pinged and hammered for updates, then increasingly you shouldn't be querying actors, right? Actors should always push forward. So if it can push that information somewhere else and receive that information, that's great.